Hi guys, today in this episode we will see how to close our wing using the function called DOM, and we will add our wingtip. Okay, we see how it looks like, and okay, I already opened SolidWorks with our wing. In the previous chapter we used the function extrude, and then we use another function to reduce the mass weight. Okay, as we can see, the mass is about 100.5 grams. So now we will reduce. This is another cool technique. We now have to remove, clicking on delete, the extruding, and then we will use extrude normally. Let's say 200 millimeters. That was, which was the other one, and then now we will use the command shell. We click on shell preview. Then, as you can see, the shell is inside the wing. So if we click yes, we don't see anything, but the shell is closed. Click on yes, and then as you can see, the shell is empty. But if we move the cut plane, we see is empty, and also the mass is lighter. Sorry. So we click on this. Now we will shell in 5 millimeters. Shell preview. Okay, that's it. Click OK, and now our wing is 50 grams lighter. Here we can check the geometry, which in fact is empty inside. And also the good advantage of the shell function is that did not add an extra measure, so we will run out our geometry. Then we will use a command called DOM, which insert features DOM. Okay, DOM. We choose our face to DOM. Then we click here, and we add the kind of DOM we want. Let's say 50 millimeters. Okay, now we have our wing ready to be studied. The good advantage of the DOM function is that did not change the geometry, so it's almost the same. And also, which is a good advantage, because did not change the aerodynamic properties. Okay, now we will save our part, and then we will start a simulation. Okay, let's do it. Flow simulation. Click on wizard, click on next. Then we choose external. External, as you can see here, is a solid in a unbounded stream. Internal is a solid, or what else, in a bounded or limited stream. Reference axis, take care of it, because if you change it, you will change all the results. So this is our reference axis, because we are traveling from in the wind from left to the right. We choose the fluid, we add the air. I'm Mach number flow now, because we are speeding. We are talking about low speed from modelism. This is okay. Now we choose our velocity in the x direction, which is 100 kilometers per hour. Here the result resolution, the higher the result, the higher the computation time required, but also the higher the accuracy of the results. For this case, we are just making an assessment, and also the geometry is very simple, and the results are common. So we'll leave it on resolution 3, then click on finish. Then this gray cube is our computational domain. So the air enters from the left and exits from the right. Nothing more, not from here, not from the top, not from the bottom, just left and right. Now, since we are studying the wake of this wing, we need a lot of domain behind the wingtip. So we click on computational domain, then let me just, okay, this view, click on the right, the arrow, and let's say 1 meter behind the wing. Then we will reduce some on the left, let's say 0.5. Yeah, okay, leave it here. Then we click on input data, click on calculation control options, and since the geometry is easy to study, and also we need only just a first glance to the result, we change in the maximum iteration in 80, and then if the result is not good for us, we will increase. Now we will add the goals. Surface goal, no, sorry. Goals, we choose global goals. Surface goal, and then we choose all the surface to apply our results. Don't forget the trailing edge, because you will make some mistakes. And then we choose what SolidWorks calculates: the density, which is important, velocity in the x direction, the Mach number, and then these all parameters are not applicable for fluidodynamic simulation in this case. Then now everything is ready. We click on run. If the simulation is well set up, there are no warnings. Okay, as we can see, there are 20 iterations left, and the CPU time was 3 minutes. So we will wait a little bit. Okay, now solver is finished. This is our wing. Now we choose on cut plots, insert it, and we can choose this face. Okay, contours, pressure, we increase the levels to the maximum, and we click on yes. And if you don't see anything, edit definitions. Okay, boom, this is one. if you want to move this plane, you can click on this arrow and then just drag. And this is our wing traveling at 20 kilometers per second, 27 meters per second. We can we move it with velocity. Okay. Then this is our drag, and you can also click on streamline if you want to study the lines. And just me show you another one thing, and then that's all. I will leave you in order to you can play up with it. We can add flow trajectories. We choose this wing, we choose lines, velocity, and this is our wing. And as you can see here, the flow is twisting. These are called the trailing vortex, and I will show you the effect. These are the main advantage of making a wingtip, rounded wingtip. We can also play. As you can see here, it's starting to twist. Stop it. We edit definition. We will choose also this face. Check out the difference of the behavior. We can choose also this one. Okay, now we can play all the animation. Looks. And these are the so-called the trailing vortices, which are caused near the wing. And the only way to, if you want to increase your wing efficiency, is to make a tip like this, like a rounded wing, not a plane, because as you can see we have a line starting as soon as possible to twisting. And we can hide this, and I will show you just the surface plot. Okay, surface plot, we choose pressure, dynamic pressure, and okay, if you don't see any kind of results, you go on definition, contours, click on this one, click on the other one. Oh, sorry, let's say total pressure, plot minimum. Okay, if you want to see dynamic pressure, we choose here, edit, choose this, okay, and this is the dynamic pressure of the wing. I hope this will help you in your assessing of the wing, and in the next chapter we will see another cool things about wings. Thank you, and ciao.